are recording. Good, okay. Right. A8. Describe an experiment that demonstrates Brownian motion and explain how it provides evidence for the movement of molecules. So, if you didn't look this up when it came up with the worksheet, you'll have a look at it now. The experiment, it's not... How can I draw this? Okay, so what you usually have here is you have some chamber, and I think the original experiment contained something like pollen, I think. You know, pollen from flowers? You needed to contain something quite small, and that's kind of just moving around freely. So you could put some pollen in here, inside of this, okay? You're also going to need some kind of light source as well. So maybe we'll put our light here. It's our light source. A microscope would be helpful. Oh, how do I draw an eye? There's an eye. That's an eye. Microscope. And then we're looking down and we're looking into the chamber that's full of the pollen. Now, when you look at it, so actually let's just get the words right. Describe an experiment. Okay, so I need to include some English. So we examine under a microscope some well lit I'm having an English problem right now. How do you spell lit when you say well lit?
L-I-T.
Are you sure?
Yeah. Yes.
How sure are you? 100%. That's a strong claim to make, so I'll have to believe you then. I wasn't sure if it was one of these irregular spellings. You still spell it. Are you sure? No. Siva says she's 100% sure, so... No, don't! She said she's 100% sure. That's a strong claim. We examine under a microscope some well-lit pollen in free motion in a chamber. Well, no, the spelling is what I was worried about. It is L-I-T, yeah. Okay. 10 out of 10 for use of English. Or what part of the EAP has the grammar part? Is it use of English? The use of English exam? Yeah. Okay. So, now that we've talked, the experiment is quite simple. I think it was Einstein actually who did this experiment. You might think from the name of it that it was brown. But I think it was actually Einstein who did this experiment with the pollen. And in fact, it was also Einstein who calculated first Avogadro's constant. So neither Avogadro nor Brown was Einstein for both. So why it's not called Einstein's constant and Einsteinian motion, I don't know. I think it was felt that, share the knowledge, yeah. Don't hog it all. Okay, so is the experiment clear? It's a very simple experiment. But now what's interesting is what you see. So can I scroll down? How might you imagine the pollen to be moving? What way would you imagine it to move?
What way?
Yeah. How would you describe this movement?
Scattering around,
Scattering around, yeah. Like, show me with your hand. How would you picture it moving?
Just, yeah.
Like zigzagging, or?
Bouncing.
Yeah, like you might think it might be moving around like this, but it's actually, its motion is much more jittery. So this is what you see. Now I'll try my best to draw it. Oh. It just, do you get what I'm doing here? It's like it's like a scribble, you know. It's not linear. It's like a scribble. So the motion is random. Well, this is the thing. It says describe an experiment. So we've done that, and explain how it provides evidence for the movement. So I need to at least say what the movement is. Now, I like to draw. If you prefer to describe it, that's fine. But I think a good drawing like this, it makes it clear. So the last part is, why does this explain that the movement, that the pollen is made of molecules? You know, how does this provide evidence for the theory of molecules? And the reason is this. So you picture you have the big piece of pollen that you can see. Then you have these little atoms which you can't see, right? Or, well, maybe not atoms, maybe molecules. Like, for example, if it's in air, what would the molecules be? There'd be oxygen. What's oxygen? O2, is it? And there'd be some nitrogen. Is nitrogen N2? And of course there'd be some CO2. And these are quite small and you can't see them. And they're moving in straight lines because they're bouncing off of everything. And what happens is they bounce into the pollen, and by conservation momentum, the pollen moves a little bit this way. But then another molecule would bounce in this direction and it'll make it move that way. And then maybe another molecule comes in here and then makes it move down this way. So what's happening is all the small atoms moving in a straight line that you can't see hit the pollen that you can see and cause it to like jerk in different directions, you know, like this way, this way, this way, this way. Okay, so this is the Brownian motion. It's caused by the atoms you can't see giving their momentum to the pollen. Sorry, I keep saying atoms, molecules, O2 and N2. So you can say the linear moving molecules impart momentum randomly on the pollen. Impart. Do you know this word? Who knows the word impart? Does anyone know this word impart? I-M-P-A-R-T.
Cause.
Like cause, but not quite cause. It's a fancy academic verb for something.
To move something.
Could be. Could be. Could be. Could be. It's a fancy academic word for really just, yeah, effect, give, cause, all this type of stuff. It's like a mixture of, you said effect and you said cause. It's like you put the two verbs together.
Influence.
Like an influence, yeah. Except influence we just use for people, you know, like you persuade them. You wouldn't really say you influence a molecule, you know. Like, come on, move left, would you? Come on. Okay, is that okay? See, but what did the marking scheme say? Did it draw a beautiful scribble like... What did it say?
Fine pollen grains suspended in the water and observed through a microscope are seen to be in constant movement. but provided the grains are small, the impacts on each side will not cancel out, resulting in movement of the grains.
Okay. The only difference between that and what I did is I put my pollen in air. I put it in like a little vacuum glass chamber, whereas in that one they put in water. The only difference is instead of oxygen and nitrogen and CO2, what molecules are hitting their pollen? H2O, isn't it? If you put the pollen in water, it'll be H2O instead. And if you're going to use water, you should draw it in on your picture. It doesn't matter. I don't know.
It says alternative descriptions such as observation of smoke particle in the glass cells are equal.
Yeah, okay, so the other one is you can put some smoke inside the glass. Which would be the easiest to look at? I guess it doesn't matter. I suppose what I don't like about the water is that you're going to have to wait for everything to be, the water to be still. You know, because if you see the pollen moving, you're not quite sure if it's because you hit the desk and you made the water ripple, you know. That's why I prefer the smoke or the pollen or the gas rather than the liquid. Okay. Next one is 9, so let me save this recording.